We're joined next by Eric Schmidt, co-founder of Schmidt Futures and former CEO and chairman of Google, and Alexander Wang, founder and CEO of Scale AI, for a fireside chat moderated by Gerrit, tech reporter for The Washington Post. Please welcome to the stage Eric Schmidt, Alexander Wang, and Gerrit.
Hello. How's everyone doing? It's funny, I didn't actually see this room, so I was like, how big of a stage are we coming out on? But this is great, very welcoming. Yeah, this is cool to do this kind of thing in person. I'm sure every single person who comes on stage is like, wow, we're in person. It's probably, even that is getting a little bit boring. But yeah, thanks everyone for coming out and braving the real world to kind of have this conversation and make these connections. I think we obviously have Alex and Eric here, and they just, have really interesting experience and perspectives. But I kind of wanted to start a little bit. So I've been covering tech for like 6 or 7 or 8 years or something. And when I started, it was like AI, and every company was an AI company. And I kind of just stopped writing about it because I was like, 90% of you are talking nonsense. A lot of this is not real. And I was, you can follow the kind of cutting edge of the science, and a lot of that was happening at big companies like Google. But there was some interesting things happening there, but in terms of the applications, in terms of people making money, in terms of business models being completely transformed, most of what people were pitching me, it just didn't feel real. And I think, the last 6 months or even 6 weeks, like some of that feels like it's really changed. And I think, Eric, you mentioned Cambrian explosion as like, a way to kind of look at maybe this moment in AI. So, I think the first thing I wanted to ask you both is kind of, can you give us sort of a tight description of this moment and, from a business perspective, where are we right now? Kind of, what is the opportunity? What is different about right now than maybe a year ago or 5 years ago? I don't know, Alex, you want to start?
Yeah, I think I 100% agree. I do believe we're sort of in the midst of an AI renaissance, and it's true if you look at any metrics. If you look at sort of the broad usability of the technology and how many people are actually utilizing basically the cutting edge AI in record time. I don't think there's ever been sort of a precedent of sort of the time from AI breakthrough to it being in the hands of millions of people in the same way that Stable Diffusion and Dall-E 2 and these sorts of AI image generation models have enabled. And I think we're entering a new world where the models themselves are platforms. This is something that actually, Eric, I think you and I had talked about years ago, was that like, hey, we're going to get to this world where the models themselves are platforms. But what that means is that now you have people building on top of them in fully new ways, and sort of there's sort of this concept of, for a while, AI seemed like a application technology. And I think we're entering a phase where it's a sort of underlying platform technology. And I think for many people in the industry, that seemed intuitively like it was going to be the case and that we're going to get there. But we weren't ever in a state where we had generally usable algorithms and generally useful algorithms. And so it's incredibly exciting. And then I think from a business perspective, I think we're about to see sort of this next era of sort of explosion of productivity from an economic perspective, explosion in use cases. So I think it's going to be a brave new world over the next few years.
Well, let's start by congratulating you for scaling a company, right?
Thank you.
Sorry for the pun.
It's not the first time I've heard it.
I'm sure. I guess I've done this so long. To me, this is just another example of how tech works. And every cycle, it feels bigger, faster, broader. It's exactly what Alex said. And what happened in the last 5 years was you had basically transformers took over, architecturally. Mm-hmm. And the combination of that and these extraordinarily powerful GPU-based architectures, TPU-based architectures, and these very large models have sort of now given us that next opportunity platform. On the platform. I think the diffusion models are particularly compelling because the simple rule is that AI used to be able to analyze patterns, but if you can analyze a pattern, you can generate something. So if you can analyze the pattern and you can learn from it, you can generate it. Well, that is a very profound shift in paradigm for many, many people.
I mean, if you're sort of running a business that is not obviously in AI, or you didn't start your business thinking about AI, I mean, should you be thinking about this, and how should you be thinking about that in this moment?
Well, this is what you do.
Yeah.
Yeah, I think now it's a really, really critical moment for companies, businesses, as well as nations to sort of really sort of realize the speed at which this technology is moving, and fundamentally embrace the fact that they have to reinvent themselves in the new paradigm, or they're going to be left behind, and someone else is going to do that reinvention.
Yeah. And it's worth noting that every incumbent says this, and very few incumbents do it successfully. So I was trying to figure out where the really exciting stuff is, aside from the big tech companies. Sorry for my bias. And the answer is the startups, right? The other large companies that are not the big tech companies are not doing this stuff because they have not been able to incorporate these new modalities, platforms, data models, and so forth into their existing data flows for whatever reason, including, for example, that they don't know where their data is, or it's not normalized, or it's not labeled in the right way, or they can't get to it, or the data center burnt down and they're not on the cloud, or something stupid like that. All of which is possible.
And it's not for lack of understanding. I think you can talk to executives at these enterprises, and they know that data is their fundamental blocker to getting to an AI future, and so they know all the problems. The issue is, where does the urgency come from? And I would argue that now you should be the most urgent that you've ever been, because you just look at the pace of progress in the open source community, in the AI community, among startups, and it's breakneck. There's literally...
And there's this weird thing that's happened, which is that a lot of stuff was invented in the key universities.
Yeah.
Then companies like Google essentially acquired those teams, right, as either through startups or by hiring the professors or the graduate students. Essentially, all of the combinatoric innovation is now occurring in these large companies or very, very well-funded startups, right? That's not the norm. And so what you're seeing now is you're seeing this enormous commercial interest in the big companies, and we can go through the specifics. But you also have the open source community following very fast. So one way to understand it is the open source community normally would be ahead, but in this case it's catching up, but the gap isn't that big.
Yeah, I mean, I want to talk a bit about that because we were talking a bit about the Civility AI event earlier this week. Maybe people in this room were there as well, and there was, some direct comments about, the big tech companies, and there's also, in my world, which is like, essentially we're maybe the haters, we're the ones who are saying, well, isn't this bad, or isn't this going to cause a problem? And we ask those critical questions. A big one that we're talking about is, proliferation, access, and, different Google, when they did their thing, and when the big tech companies do their thing, they're careful about what they release, what they don't release. Largely that's for business reasons, but there's also, is this a technology that we want anybody in the world to have immediate access to? And then you have OpenAI's model, which is sort of to do that a little bit more, but also to be careful about what explicitly they release to the world. And now you have these much more open source movements that are saying, look, like we were going to trust the world, and we also don't believe that commercially these things should be controlled by the few. They should be controlled by the many. So, I mean, this is also a big conversation that's happening right now. And I mean, I don't know where you place your company in that or how you think about that.
Yeah, well, first off, I think it's super interesting. I think a genie's out of the bottle, right? I think that in some part because of these open source efforts, we're in a world where there's, we're not questioning when AI is going to get to mass adoption, or if it's going to get to mass adoption. We're questioning when, and so I think that's the first major paradigm shift. I think our view is that even with the open source technology, there's still massive gaps, and there's still parts of the world, like the United States national security enterprise, these large enterprises that really have not yet adopted much of this technology. There's these massive swaths of the old economy which require access to this technology as urgently as possible. And I think it's necessary for our view at Scales. How can we help bridge that gap and bring these breakthroughs to those organizations?
I mean, it's sort of a related conversation, but Eric, I know in the book that you did recently, there is concern about proliferation and about bad actors having access to this technology. So, I mean, how do you kind of square that risk with the need to get this out to more people and democratize it?
I think Alex got it right. I had hoped 3 or 4 years ago that the really powerful stuff would stay inside of industrial labs. and that the people leading it would restrict it. For example, OpenAI did that with GPT-2 for a bit. But I think the sort of cultural pressure and the way sort of the I don't know how to describe it, the liberal democratic thinking causes this kind of sharing. And it's often done with a very naive understanding of how these things will be used. Yeah. So you can be sure that the people who invented vision systems did not think that their vision systems would be used by the Chinese to track Uyghurs. Right. It was not on the feature list, 5 years ago. They were building this for this. And so if I were one of those developers, I'd be embarrassed that my technology had been misused. I guess you could say the same thing about the telephone. But the important thing is it's naive. And I want to be very clear, it's naive to assume that this technology is not going to be used by evil people, right? To somehow trust the community. Well, unfortunately, the community, if it's a large enough community, there is at least one bad actor. And let me give you a couple of examples. A bad actor could easily weaponize the generation of malevolent viruses using basically the transformer tools that are now so popular, plus a large database of biology. Another bad actor could easily use these tools to do highly targeted offensive attacks on specific individuals. A bad actor could use these to generate very manipulative disinformation to change a society, to change an outcome, to cause a riot, to cause people to be killed, right? So I'm not suggesting we shouldn't build it, but I would like people to say, we're building this amazing platform, comma, we need to figure out a way to keep this under control, to detect it, to police it, or to monitor it.
Right. And relatedly, a good friend of ours, Jared Cohen, I was talking to him about this recently, that I think technologists need to undergo geopolitical training, just in the same way that they go through other trainings for their job. Because he mentioned this story around Ian Goodfellow, who's the inventor of the GAN, the General Adversarial Network, which was the precursor to a lot of the diffusion models and image generation models we have today. And he, obviously this technology is very exciting, it's very interesting, it's very cool. He brought Ian to speak to former Russian and Chinese intelligence analysts, and he asked them, what could these image generation models be used for? How are the Russians going to use them? How are the Chinese going to use them? And what are the negative externalities of those? And I think that level of understanding and, frankly, awareness is really necessary as the technology continues improving and getting better.
I mean, so you have government clients, right, at this point? I mean, so, do you, when you have conversations with them, I mean, and whether it's the U.S. government or maybe other ones, I mean, are you hearing these concerns? Are they saying, yes, sell to us, but don't sell to XYZ client or state? Or, how do you, I mean, you're having these conversations right now that are business, that are strategic. Who do we want to work with? Who do we not want to work with? How, I don't know if you're able to provide any examples, but how are you dealing with those kind of tough conversations right now, or are you even having them?
I think the first one, frankly, was our strong commitment to United States national security. And we made that decision because, I grew up in Los Alamos, New Mexico, where the atomic bomb was first built, the Manhattan Project, which I think is a very important lesson for us all to sort of grok and understand. And it was this sort of clear technology breakthrough that had very, very meaningful implications for sort of global affairs and global events over the following decades. And I think that AI technology is a very similar kind of technology. It has similar implications for world events, for geopolitics, for, frankly, the sort of battle of the free world versus authoritarian regimes. And we made a strong commitment. This was years ago, probably back in 2020, when we made the commitment to work with the United States government and use our technology for a strong defense. Eric also has been very deep on this issue, led the Defense Innovation Board, among other organizations, and sort of has been a leading voice in this topic of utilizing AI for national security.
Well, I think that the situation in Ukraine is a really good reminder that we collectively need to be in favor of democracy. And when you look at what's going on in China, and we can get into all of the details of what's going on in China and Russia, we really want to be in democracies. So let's start with that. So what we're doing had better be consistent with the principles of democratic rule and leadership and voting and all of those kinds of things. So I always worry when they're not in alignment. To answer Alex's question about his company, for the other companies, you would say pretty much everybody now has an AI ethics group. And what happens is that there's some question comes up and it goes to this ethics group and they decide. Most of the companies that I'm aware of have, they try to not be on the offensive side and they try to be on the defensive side of national security. That's how their AI ethics group come out. The only problem with that is that in conflict, defense and offense can often be the same. So these are examples like missile defense systems get very tricky because of that issue. As part of my work with the military, we wrote, and the military adopted, the U.S. military, an AI ethics for the U.S. military. And so, which I'd encourage everyone to read because it's all in public. So I think it's worth saying AI is important enough that each of us need to have our own sort of AI ethics rule. Our corporations, our universities, and our governments need to do it. And I hope that they're consistent with democratic principles.
Right. I mean, you know, like, are we in sort of a space race specifically with China when it comes to this technology? Or is that idea a little bit too zero-sum and maybe even self-fulfilling? Like, are we in this point where there's no going back? You know, it seems that the hedges are going to go a little bit higher and higher with technology, or should we kind of pull back the clock 10 years and say, hey, well, technology can be a way to extend American culture and American values, and maybe we should be careful about how closed off or maybe even how militant we're getting about some of these conversations?
I think it's unavoidable. I mean, I do think the hedges keep going up. Part of that is inherent to the technology. So one of the big breakthroughs of artificial intelligence of recent years is sort of this realization that scale really matters. Scale, not the company, but scale.
I mean, it's a good name, right?
So, it's a good name. It's very relevant. But the sort of amount of data you have for these systems, the amount of computational power, the size of the models, all these things really, really matter for the power of your AI systems. And that setup, it's almost like how the size of your nuclear warhead stockpile is a dimension upon which proliferation will persist. This is just another example where the models are just going to keep getting bigger and bigger and bigger and do more and more incredible things and more sort of innovative tasks that have the potential for both good and great potential for harm. And so this sort of race with China or Russia on AI, I think, is somewhat unavoidable, partially also due to the values misalignment that Eric was mentioning. We in America, we're going to be thoughtful about using AI for democratic values, but those same values are not present in how China is going to use the technology or Russia is going to use the technology. And we need to just be real about what that might mean for how the technology will proliferate.
I think the correct word is exactly, we've obviously worked together on this for a long time, we're using the same words literally. He's exactly right when he says race. It's a race, not a war. Right? Wars are different. We understand what war is.
Yeah.
So
because sometimes people mix those up, right?
Yeah. Well, again, study Ukraine to understand I was just there. The horrors of a real war, and I say this with great respect to the military leaders that are in the room. So it's a race for a prize that's important, and that race is to set standards for global information flows and communications around the world. In that race, we, the United States, have managed to lose the 5G race definitively, which is a source of great frustration for me every hour and minute I'm on the freeway. An example is I'm in Ukraine and I'm on the train, because you can't fly there, and we have a Starlink on the roof of the train, and I have 200 megabits. Now remember that the next time you're on an Amtrak train. But getting back to the things we've lost.
We have a low bar for our public infrastructure in this country.
Yeah, but why?
Yeah.
This is the wealthiest and most successful country on earth last time I heard about it, which was in grade school, which was a long time ago for me. So, look, the important thing is, in this race, China is a very, very well-organized competitor. They have a model which is called civil-military fusion. What they do is they pick national champions. They give them an enormous amount of money. This conference is not about quantum, but quantum is now getting 3 times, 5 times, 10 times more funding in China than it is in the West, right? And we know it's just at the beginning of its implications, all sorts of national security issues. So a thought experiment to think about is, let's imagine that in 5 or 10 years, whatever time frame you choose, we have a system which is partial AGI. It's capable of setting some objectives, it's interesting, and so forth. How would you feel if it was a Manhattan Project with your background, but one run in China, right? You'd be pretty upset, right? We want to make sure that if there's any chance for that kind of technology, we want it to be built in the West and controlled by the West.
I'm going to go to questions in a minute, so if people want to think about that. But the one thing I wanted to ask before that is, then you just sort of described China's industrial policy about how they're approaching it, and the state is very involved in that to the point where they may be telling business leaders what to do and what not to do. That's, when it comes to AI regulation specifically, but I'll say tech regulation broadly, the U.S. government hasn't really done anything in the last, decade. And so I'm wondering, should there be more involvement between private companies and the state? Do we need, specific kinds of regulations, maybe like what Europe is doing, prescriptive ideas for how AI should develop? Or are we okay with this more kind of open, free market system that the U.S. has sort of championed and continues to do? I don't know, Alex, because you're in the midst of it, right? So,
yeah, well, I'll say one area of this where I have a very strong perspective, which is, again, on national security. I think that it is, if you look at all of these recent AI breakthroughs, or even the AI breakthroughs over the past 20 years, the vast majority are American technology. American companies have really built and created this incredible technology that is very, very powerful and is going to fundamentally change the world. And then you look at the sort of bridging of that gap towards applying to our national security problems, and we're in this strange world where the leading organizations that have created a lot of the technology have really sort of either refused or just sort of abdicated from supporting the United States national security objectives, and that fundamentally needs to change. We need, I think there was an event called The Hill and the Valley. We need to bring these two communities very deeply together, and the most innovative technologists need to be thinking about how can the technology be used for United States national security objectives, and bringing this technology for use, for defense, for intelligence, for all these purposes. Otherwise, I think we're at great risk. And so I think on this dimension in particular, I think it's absolutely critical. And I think that the nature of the technology, last piece on this, is that it's massively acceleratory. Just like how the internet in the early days up until now has felt like this sort of unending, ever faster treadmill of sort of technology and pace. And AI is going to be no different. And so every waking week, month, year that we don't take action is sort of a missed opportunity or mortgaging our future in ensuring that we have access to the best technology.
There's a tendency for the people who think they're winning the race to then declare success and stop competing. If you look at what China's doing, and to some degree Russia, but really China, this race is going to go on for a long time. So it's really important when we develop these new platforms that we keep innovating, right? There's lots of good news here. There's lots of money in the industry. There's lots of really smart people coming in. The number one major in all the leading universities is now computer science, and a lot of them are doing AI, ML, and so forth. So we have sort of the generational shift that we need. But in our political system, I'll give you an example. USICA, which formerly the CHIPS Act, $250 billion. We're going to need another one of those every few years because we're going to need more government funding and participation to move these key industries forward. It won't happen just by universities and private sector. That's an example of how you have to fight and win. But we can win this.
Yeah, but we do need more public funding and more government money as well. Okay. Do we have any questions? Do we have a mic that I know we were kind of doing it on the fly, so I want to make sure there is actually a mic that's going around. But
we have a question right here in the front.
Okay, go for it. Yeah, I guess just...
I'll have to repeat your question.
Oh, and then I'll do over there next. We have a mic. Yeah, it's okay, just so everyone can hear you. Right here. And then we'll go to this one next. Yeah.
Alexander Demling, I work for Der Spiegel, German magazine, and I was wondering, how much of the regulation you're talking about the kind of work, military, private sector, how much is, now that we've seen with this Russia-Ukrainian war how the West is threatened in our security, how much is possible on a NATO level, like cooperation between nations, and how much needs to be in the US and with the US military?
Well, first place, the US military is doing lots of stuff using AI. Let's start with Project Maven, which involves better vision systems and these sorts of things, better signals intelligence. I was just in Ukraine, and one of the things I wanted to see was how did the tech industry, what did it do? And in this particular case, Starlink really made a difference because it allowed the Russians' blockage of the various internet ports not to happen. They put everything in the cloud in day one. It was illegal to put stuff in the cloud if you were in Ukraine, and they changed that in one day in case the country was overrun. And then they built an app called DIA, D-I-I-A, which is basically sort of think of it as a passport app. And they put in an ability to take a picture which is geolocated, and they have good things to address false use and so forth. And you submit the picture. It's classified using a tank classifier, essentially. What kind of tank is it? They geolocate where the tank is, and then a human makes a targeting decision. So that's an example where the technology is used in a very straightforward way to help them fight, essentially defend themselves. I think from the standpoint of the Ukrainians, they have this extraordinary technical capability for all sorts of reasons, and they've also been under attack from the Russians for basically since before 2014. So I think they're going to do fine, right, if we continue to help them with the kind of information that they need.
The question over here, yeah.
Yeah, hi. Loretta Tivarela. I'm actually a founding and managing partner at Next Sequence. You have mentioned technologies like AI, but also now actually quantum computing. What is your view about tech bio and what it means in terms of the future of tech bio? Where do you think the industry going and what is actually missing to make it as important on the agenda as AI or quantum computing?
Alex?
Yeah, I think, I think that the really interesting thing, again, going back to this concept of AI as a platform technology, has been is the ability to utilize AI as a tool to progress virtually every other industry. But biotechnology, I think, is one great example where artificial intelligence is having a very meaningful impact. DeepMind released their AlphaFold protein folding algorithm, and then I believe earlier this year they released a database of, I think it was 400 million proteins, but basically the universe of all proteins that we as humans know of, folded by AlphaFold. And so we're at this point where, and if you talk to Demis at DeepMind, one of the things he's very passionate about is AI as a tool to accelerate all of human science. And frankly, AI being this tool that's going to allow us to sort of solve science to a large degree. And so I think that this is like the right way to think about it, is almost in the same way that the microscope accelerated science or the computer accelerated science. We now have this new tool, artificial intelligence, that's going to massively accelerate outcomes in biotechnology and make it so that we're going to, I truly believe, do a much better job at identifying new treatments, being able to do better drug discovery, and other sorts of advancements in the field.
I can give you an example of chemists. So you talk to a chemist. What do chemists do all day? They basically organize things in these complicated chemistry sets, right? And they all have complicated relationships of energy and bindings and so forth. And what they want is they want the computer to help them do that. And these tools allow them to do that very quickly. But more interestingly, once they get something that works, you can, for example, use quantum simulation and eventually quantum computers to sort of optimize essentially the low point of the energy state of this particular thing. You can actually make it more buildable, more effective, and more sort of reliable, if you will. And the chemistry terms are more complicated, but you get the idea. So that's a good example where the underlying science platform that you're describing really affects your life, because you will eventually, as a result, have a better material, a better liquid, a better substance, something better on the supermarket shelves or in your home or on the floor or in your car or whatever because of that. Synthetic biology is probably the next really big one. And the simplest way to understand it is the people who are in synthetic biology think that 60 to 70% of the built world can be grown instead of built, grown in ways that are more climate friendly, if you will. So you can grow concrete and bricks. Today, there's lots of synthetic biology around drugs and perfumes and liquids and things like that, biofuels and so forth. So the Biden administration has a whole SynBio program. A couple $1 billion have been applied to that. That's another big one coming.
We have one right here. Question right here.
Hi. I'm Nicholas Burgham-Adams.
You can go next, but he'll go.
I'm Nicholas Burgham-Adams from Goodley Labs. I really appreciate the concern about geopolitics and the idea that we're in this race or this rivalry that's so important. I wonder if there's another front in which to engage that and your thoughts about it. So apart from the military front, it seems like it's plausible that some of these technologies and some of this perspective could be used to kind of support and pro-social technologies, tools and technologies that kind of produce the precursors of democratic culture and spread that at scale with internet communications technology and some of these exponential AI technologies. I'm wondering if you have thoughts about that.
One of the, I think it's a really interesting idea, and I think one of the core concepts here that is actually one that I'm quite excited about personally is the utilization of artificial intelligence for education. And anyone can play with one of these sort of large language models and realize that they're pretty powerful. They're reasonably conversant, and there's a pretty immense potential for them to serve as sort of a scalable way to massively increase the bar of education globally. And I think that speaking of precursors for democratic ideals or pro-social ideas, I think that really begins with education and an understanding of these different ways of humans to organize and what the implications of those methods are. And so, I think one area that education in general from a technology perspective has been horribly underinvested in, but the utilization of artificial intelligence to offer more scalable, better, and more personalized education, I think is a massive change that's going to fundamentally change the curve of human potential over the next, call it 5 years.
Exactly right.
Yep.
Hi, my name is Stephanie Scher. Could you perhaps speak a bit on the role of chip production on the global AI race, and then what you see happening on the political front, maybe specifically starting with TSMC?
To review the facts at the moment, TSMC is making 5 nanometer chips and is announced 4 nanometer chips, which are in production now. Somebody bought essentially a mining computer that had a SMIC chip, which is a Chinese chip. And this particular chip, which is a specialized chip, used what appears to be a copy of the 7 nanometer TSMC manufacturing, which is done by an earlier technology of manufacture than the current 5 nanometer ones. This was a shock to a lot of people. SMIC has since announced that they're going to offer 5 nanometer chips in the next year. So a reasonable prediction is that if the ASML block holds, which is likely to, for the next few years, China will be in the 5 nanometer world, and the West will be in the 4, 3, and eventually 2 nanometers, which is where Intel is trying to go in their Ohio plant, as best I can figure it out. So is that enough of a difference to make a big difference? Well, here are the numbers. The vast majority of chips and chip packaging and so forth are made in China, not the chips themselves, but everything else around it. And most of the chips that we use every day are much slower, that is, greater nanometers than 5 and 7 nanometers. So as much as we worked hard to reshore high skills chip manufacturing into the United States, the fact of the matter is the Chinese have gotten close enough that it's a serious race. I think the best thing to do, and part of the CHIPS Act has this in it, is to try to figure out a way to change the design tools to use AI in the layout and also do 3D packaging of the chips. And the combination of changing the layouts and the 3D packaging can probably give us a step up, again, in the race. But again, these are controversial ideas.
Hi. This is a question for Eric. So in macroeconomics, we have the Federal Reserve, which is a very, very competent body of PhDs and others. When radio and television came about, we had the FCC and so on. What's your take on institutionally where the country is missing out? So we can do legislation after legislation like the chips, et cetera, but what would be your prescription institutionally? Like what institutions need to come to existence for us to be a serious player in AI globally?
Well, first, we are the serious player in AI, so we've done a good job in the current structure. Your question is usually interpreted as, do we need a Department of Internet Regulation? And the industry's answer is no. The existing regulatory bodies, which includes the SEC, the FTC, there's a long list, are sufficient. The Europeans disagree with that, and they now have basically the digital services agreements and so forth to try to regulate it further. I've been trying to come up with, if I were God, which I'm not going to be, and I'm not today, how would I do this? And I've not been able to write down, personally, a rule that both captures the frustrations that we all have about the internet, but also is not amenable to political challenge, mission creep, and or violations of the Constitution. So let's give you an example. Let's say you don't like the way social media works, which many people don't. Try to write down the algorithm that you would have them use instead of the one they do. Okay, well, that's hard, but let's say you do that. Now, given that the company doesn't want to do that, try to write the regulation that enforces them to implement that rule in such a way that future politicians don't change it, right? And we don't have an answer to that. This stuff is too new. We don't have a consensus on what makes sense. And furthermore, since I'm not God and our political system is clearly broken, you have to come up with the nanosecond in our society where the Republicans and the Democrats agree on anything, right? And at that nanosecond, you have to hand them this piece of paper, and they have to say, this is our only choice. We have to do it because we only have 1 nanosecond to regulate this industry. And I think that's where we are. Yeah. Sorry.
Yeah, trying to report on AI or any tech regulation sounds about right. It's kind of like, why are we even doing
I have one more obnoxious comment. Yeah. I think we should rename the word regulation to regulation and growth. If you look at what the Europeans have done, they've managed to have a typical European Brussels process. You can tell I've spent a decade trying to deal with Brussels, and I have some scars, which takes forever and is very complicated and very painful. And the problem is they're trying to regulate AI, but they're not growing in AI. They're regulating the other countries. They're not regulating their own because they're not doing the innovation. What they should have done is they should have had a growth and regulation team. I was fortunate to be the chairman of the National Security Commission on AI, and we had the dual goal. And so we studied the question of how to grow, right? And by the way, the best way to grow is to let foreigners who don't want to work in China come and work in the United States in our companies, right? This is not that complicated, right? It's the first thing. And I can go on, but something like 65% of the innovators in the top pages are all foreign-born. Right? I'm sorry, Americans. The other people are smarter than we are. It's okay. We let them in. That's how we all got here in the first place. It's a nation of immigrants, and I can go on.
Well, yeah, as an H-1B holder, if y'all can figure that out, I'd really appreciate it. Or you can come visit me in Canada next year. But do we have maybe one more question in the audience? And then where's the mic holders? Yeah, is down here? Okay, excellent.
Thank you very much, Eric. I actually agree with you. I think education seems to be the biggest problem in the United States. So do you have any insights how we can actually make a United States education system, especially before the college, make that more effective and bring in more STEM students?
It's a big topic. I mean, I think that it's clear that there's other systems of education that are better than the American system, but I actually don't think the right approach necessarily is to sort of try to replicate those systems. I think the best approach in this case is to try to race ahead technologically. And so, I think, again, just to sort of paint the vision, if there were a world where there were an AI assistant that sort of was able to perfectly pace your educational journey and understand exactly the areas that are giving you trouble in learning any sort of topic, and then help you along those nuances and dramatically reduce the frustration in the process of learning anything new, I think that's a very compelling vision. I think that's going to result in humans learning far more than they do today, and it's going to result in a far less frustrating educational process. And so, in this case, I'm a full tech optimist, where I believe that there's lots of issues in the current education system. There's a lot of sort of local minima that we're in terms of regulation, as well as how a lot of the system works. But I think that the best approach is going to be one of technological progress.
I wonder if one of the things I want, like that the challenge from my end is kind of explaining a lot of the stuff to regular people and meeting them where they're at, while also not oversimplifying and also not hyping things up too much. And I think some of the the image models that we've seen with Dall-E and with Stability AI has really blown that into the public in a new way. And people might see these images, and then you have to tell them, yeah, like a machine made that, and they still don't. They're like, wait, what do you mean? But I found it to be a really useful way into talking to regular people who don't come to AI conferences about AI. And I'm just wondering what the two of you think about. Where is the general public at? Are there ways that as a community we can be better to help people understand in an accurate way what AI is and what it means for their lives, and what they should know about it or prepare for it?
Eric, you're the expert.
Well, people tend to learn from fear examples, like, what happens if, what happens if. But I think you're much better off with the positive examples. Like, everyone can be an artist, everyone can be a musician. I mean, there are very few really talented people like me. Like, I'm not talented in this area, but I can be almost as talented as a famous person. That would be fun for me. Right? I was thinking about a presentation where I want to do a picture involving drones in an unusual thing, and I thought I'll just have Dall-E 2 do it rather than me, because it'll take me forever to try to draw it out, and it'll look terrible. So I think once it becomes part of your daily life, right, it isn't magic. So think about where we are now. I was thinking about it as coming up to San Francisco, because I've lived in the Bay Area for 45 years, right? As I come up to the Bay Area, come up 101, I'm on my computer, on a fast network, working on these hard problems. People are sending me all sorts of attachments. I have all these dynamic things going on in my workspace, and I've got all these people texting me and so forth at the same time. When did this happen? When did I lose control over my commute? And the answer is when the phone showed up, because the phone was personal. And we don't remember a time when we didn't have smartphones, and yet they're only 14 years old. And the first ones were not nearly as useful. And it wasn't until roughly 10 years ago, when the app stores and these things took off. It was only about 5 years ago when this kind of image modeling stuff really played out. It's that new.
Right. I made my Halloween party invite with Dall-E too. Looks, I don't know, but I'm still not very good at like prompting those things yet. But
it turns out they're very sensitive to the quality of prompts.
I mean, that's where the skill comes in, right? That's where
they're going to be a machine learning model that takes your prompt and generates a correct prompt.
Yeah, right.
I know how AI people think.
Anyone wants to invent that, but yeah, I don't know. I mean, you have to deal with or not deal with, but you sell to people who aren't experts, who aren't technical. I mean, how do you think about that question?
Yeah, I think the big thing is almost like very similar to what Eric was saying. The use cases for artificial intelligence in your life have almost nothing to do with the underlying technology. So when we talk about artificial intelligence, usually we're talking about neural network-based architectures that do incredible things with sort of unstructured data. But that, the underlying, as with any technology, the underlying technological implementation has nothing to do with what the place it's going to have in our lives. And I think that it's going to do everything from make it easier to communicate with people and sort of have live translation with the people you care about the most, all the way to this sort of like unleashing of creativity via these image generation models, to all of a sudden enabling us all to be great writers with these sort of like writing tools. And each of these things are different use cases and different value propositions to us as humans, which means that I think, frankly, it's going to be woven into our daily lives, much like the internet has. We're going to have an app like Uber and an app like Instagram and an app like Twitter, and these all occupy different spaces in our lives.
I mean, generative design is going to have a lot of implications. If we go back to the Uber revolution, we started with smartphones, a little bit more than 10 years ago here in San Francisco. I think the next one is going to be about generating things that are not physically possible. The most obvious ones are basically deep fakes of people who are no longer with you, right? Where you can almost talk to them and show your grandchild what your grandfather sounded like. And these kinds of things, when they happen, and they're coming pretty fast, people are going to notice, because that's something you just can't do. Yeah. If you go back to, Amazon was the world's largest bookstore, and it was bigger than any physical bookstore. And I remember when Amazon, that's a really cool idea, right? So there are going to be ideas of that scale that will affect people every day.
Okay. We're right at time, so thank you both very much.
Thank you all.
Thank you all.
So much.
Thank you, Alex. Thank you, Gerrit.
Thank you, Sarah. Appreciate it. Thank you, Eric.
Thank you.